Hey kids! I'm going to talk to you a little bit about the photoelectric effect and the work function, what that is, okay? So, I'm going to start where we always should start, which is with a picture as far as like what's going on. But essentially, the photoelectric effect is another or one of the like the big proofs that hey, you know what? Light actually is a particle because if light wasn't, if light behaved like a wave, you wouldn't get the photoelectric effect. And the photoelectric effect is essentially how all things like if you have something like a solar-powered calculator, that's how that works. It's the photoelectric effect, you know, and obviously, you know, solar panels. That's how it works. But if we start with our picture, you have to have. Usually, it's something that's metal. So this is a metal object, metal plate, metal whatever, the little strip right there, okay? And then I'm going to have a photon that is going to come down and hit it. Okay, so here is my photon that is going to come down and hit it. Can you see my photon up there? Okay, so my photon is going to come down and hit this thing. Now, if this photon has enough energy, okay, it will knock an electron off of this. And then, hey, you know what? I could have a moving electron, and then if I have a moving electron, guess what? I can power something like a calculator. I can generate electricity. So if you think about this in terms of energy, which is one of the things we're going to be talking about a lot all year long, is this idea of conservation energy, just different ways. But if we talk about this in terms of energy, all right, well, I start with the energy of my photon, okay? So, which is this, okay? This comes down and hits my metal. Now, if this energy is not big enough, I won't knock any electrons off of my metal. If the energy is big enough, then I will knock electrons off. So like if you look at your equation, that's what this is talking about. So this is called the work function. Work function. In order for my little, you know, light, my photosensor here to work, my photocell to work. Sorry, I had a little brain fart there. But in order for my photocell to function, in order for it to work and function, I have to have a photon with enough energy. So really what this work function is, it's the amount of energy that is needed to knock one of the outer electrons off the metal. Now make sure you guys understand, and hopefully you do understand this, that metals are good conductors because the outer shell, the electrons in the outer shell, are free to move around. Okay, so really what we're doing here is we're taking one of those electrons in the outer shell and we're knocking it off the metal. So that I start with my energy from my photon, I have to overcome this energy that's holding the electron to the metal, and then my electron is, here's my little electron, it's going to be moving. So therefore my electron is going to have kinetic energy, which if you look on the equation sheet, it's actually written like this. K max equals, it's written like this. I prefer to write it like this because this is really the way it's happening. I start with this energy, I have to overcome some energy from the work function, and what I'm left over is my electron moving here, okay? Which is my K max equals HF minus the work function. Now the reason this is max, okay, is that let's say, okay, that I have, I don't know, I'm just gonna make up some numbers here. So let's say this has, okay, you know, 8 electron volts. My work function is, so I'm gonna get 8 electron volts minus 2 electron volts. That is going to equal 6 electron volts. Well, that's the maximum kinetic energy my electron could have. My electron could have 5 electron volts. It could have 3 electron volts. This is just the maximum that it could have, okay? So that if all of the energy gets converted perfectly, that's the maximum kinetic energy you can have. Hopefully that makes sense. Just a little side note, remember guys, if there's a question that says, hey, how fast is my electron actually moving? So you're going to do 1/2 mv squared. You can't use electron volts. You got to convert that to joules, okay? But hopefully that makes sense as far as the basics with the photoelectric effect. Bye, kids.